This lesson is for Advanced Algebra 7-4 on compound interest. Because we'll be dealing with this formula, students will need to be raising to a power, and so students will need a scientific or a graphing calculator when doing this lesson. The formula for compound interest is given here. Compound interest is simply interest that earns interest. So particularly when you're working with a savings situation or an investment, you want the money to grow and you want it to grow as quickly as possible. So you want your interest to be compounded when it's a investment that you're making. When you're borrowing money, you typically don't want the money to be or the interest to be compounded because that just means you're going to owe that much more interest when you pay it back. The formula, whether you're borrowing or loaning, borrowing or investing, is going to be the same. You're going to start with the starting amount, usually called the principal amount. It's the original amount that you're investing or borrowing. The formula always has parentheses next with a 1 in front, and then you'll add to it whatever the interest rate is for the interest that's being compounded. Usually that number will be given to you in percent form. When you plug it into the formula, you'll need to change it to a decimal. As a high school student, I'm assuming that you are good at converting percents to decimals. If you need help with that, please ask me for individual tutoring. When you divide that decimal by the letter n represents how many times it gets compounded. If it gets compounded once a year, that's considered annually. If it's compounded twice a year, that's called semi-annually. Quarterly is 4 times, monthly is 12, and daily is 365. Keep in mind that sometimes the book asks you to use 360 instead of 365, so if they do ask you that, just use whatever they recommend. There's one more here that I neglected to type. I apologize. We need to include here weekly as well. So weekly would be 52 times compounding. Notice that the n value is in the formula 2 times. It's under the percent. It's also being raised to a power. And then also your power indicated here is with the time, and the time is usually listed in years. So let's go ahead and try an example. Tony bought a soundbar for his bedroom that cost $1,050. Because he didn't have the money, he paid for it with his credit card. Credit card compounds monthly at 10%. If he pays off his credit card in 5 months, how much will the soundbar have really cost him? So we're going to start out with the amount that he borrowed, $1,050. Formula always has 1 plus as its next item. Then we take the percentage and change it to a decimal. 10% as a decimal is 0.1. Divide by the number of compoundings, which is usually indicated by a word in your problem. And it looks like it said compounded monthly. So we're going to use a 12 for the n, raise it to the 12, and then be careful here because we're talking about 5 months. Our time here is not going to be a 5, it's going to be 5/12 because that's the portion of a year that we're using. So the t usually is in years, so if you're working with months, you need to put it in fraction form. So then you'll just simply type this in on your calculator, type it in as is with the parentheses. I put in the caret symbol here just to help remind myself that I need to raise to these powers, not just do multiplication. So when you type that in, you should get, this is a money question, so you should always put the $sign in front. I got $10.94 and 49 cents. Money questions should also be always rounded to the nearest penny, so 2 decimal places. So to find out now how to answer the question, how much will the soundbar have really cost him, let's subtract what he originally paid. So he originally paid $10.50. If we subtract those, it ended up being an extra $44.49. So he paid $10.50 to the credit card people. The credit card people gave $10.50 to the people that paid for the soundbar, or the people that made the soundbar, but then the credit card people kept an additional $44, so it ended up costing him $44 more than what he originally thought. So he paid $10.50 to the people that he got it from, and then he paid an additional $44.49 to the credit card people. This is supposed to illustrate to students that when you use a credit card when you can't afford something, you just end up paying more money. and all it does is feed the credit card companies more money as well. So hopefully this will help discourage students from using credit cards when they can't pay for something. There are emergency situations where you need a credit card, but usually it's not to buy fancy equipment that you don't need. Keep in mind too that a lot of credit cards typically have percentages that are much higher than 10%, and they usually compound more quickly than monthly. So these numbers do rack up awful quickly. Let's try another problem. Lisa puts $10,000 in a 6-year savings certificate. A savings certificate is like a savings deposit or an investment. And the interest compounds daily. How much interest will she earn during the entire 6-year period? So we've got, let's do part A down here, her $10,000 investment, 1 plus the percentage as a decimal, move the decimal point 2 places to the left, so we get 0.05625. Always include all the digits that are available in your percentage. Divide it by the number of compoundings. Again, the number of compoundings is usually a word in the word problem. Daily here would be 365. If they want you to use 360, they would mention it specifically. We're going to raise it to the 365 again and multiply by the time period. In this case, 6. When you type that in, it should generate the number $14,014. It didn't have any decimals after that, so we don't need to worry about rounding it any further. So that's part A. Notice what that answer gives you. When you generate the compound interest formula, it gives you her original investment plus all of the interest. So there's an additional $4,014 in interest, which is what they were asking us to give. So we took the answer that we got minus her original investment. So she made an additional $4,014 by simply leaving her money in the savings certificate. Nice way to earn money, isn't it? Most savings certificates have a much lower percentage. I don't think most people could find anything higher than a 3%, but that's still money that she didn't have to work for, which is a nice way to make money. Let's talk about how to do part B. How much interest will she earn in the 6th year? Many times students will say, let's just take the $4,000 in interest that she earned and divide by 6. Remember, however, that when you do compound interest, each year you're earning more and more interest because last year's interests will earn interest as well. So each year you don't earn the same amount of interest. Each year you're earning more interest than the previous. So just dividing by 6 won't tell us what we need to know. So the way that we figure it out is we calculate the total for the first 5 years, the total for the first 6 years, and then subtract the difference. So we're going to do the 6th minus the 5th in order to answer part B. So we have the 6th already. To save time on your calculator, go back and highlight your original calculation, hit enter, and all you'll have to do is change the 6 to a 5. When you do that, you should get the new amount, which is $13,247.60. When you subtract those, you get $766 and 44. And 40. And so in year 6, she earns $766.40 in interest. The last thing we need to talk about, I'm not going to do an example for because the book actually shows a real easy example here. I'm just going to try to quickly summarize or explain. So this information is taken out of your book from page 475. If you're asked to calculate the APY, or the annual percentage yield, all you're doing is comparing savings plans that compound by different amounts. If you're compounding yearly versus quarterly, but you have different percentages, it's hard to know which one is the better investment. So what we do is we recalculate all of our different options with a 1 for the principal and a 1 for the time. By using a 1 for the principal and a 1 for the time, all you're focusing then on is how much that money's going to change according to the compoundings and according to the percentage. So when you calculate it that way, you'll end up getting a 1 with some decimals. If you ignore the 1 and look at just the decimal and turn it into a percentage, you'll have your answer. So here's what happened. We wanted to find the APY of an account paying 5% interest compounded quarterly. And we're going to say then how much that would be if you compounded annually instead and how that would compare. So this means that an APY on an account that pays 5% interest compounded quarterly would be the same as an investment that pays 5.09% interest compounded annually or only once a year. So it's a nice easy way of comparing different types of compounding.